All right, so section 13.2, now we're going to get into some more variety of different types of equations of lines. Okay, so first one is the point slope form. And what the point slope form does is exactly what it says. You're given a point and you're given the slope and you need to write the equation of the line. Now, this is a really fast way of being able to do it. You don't have to, I know you guys learned last year to plug in your slope and plug in x and y and then solve for b, but we don't want our equation to be in slope-intercept form. We want it to be in point-slope form, which means that we just have to plug in the x and y coordinate of our point and then the slope, and you don't simplify, you just leave it alone. Okay, so this is really nice, really quick way of doing this. So y minus y1 equals m times x minus x1. This y and this x are the variables of your equation. The y1 and the x1, those are the coordinates of the point that's on your line. So here's an example. If they tell you that the slope is 3 and the point is 2 comma negative 4, find the equation of the line. Well, that just means that 3 is going to go in this spot, negative 4 is going to go in this spot, and 2 is going to go in that spot. And the only kind of simplification that you would have to do here is, and really you could do this right away, is the minus a negative turns into a positive, right? So this is really y plus 4 is equal to 3 times x minus 2. Notice I'm not distributing the 3, I'm not moving the 4 over, I don't really care what the y-intercept is, because all I'm focused on is what is the equation of the line, not now I need to graph the line, so I want it in slope-intercept form. All right, so you guys have to train yourselves to use this form and not the way that you learned last year. I know it'll be hard, but trust me, it'll be much better. Okay, so what happens when they don't give you the slope, but instead they decide to give you 2 points on the line? Well, if you remember, we do have a nice formula to calculate out the slope if we have 2 points. So the first step you're going to do is to actually just calculate out what your slope is using your slope formula. Okay? And then once you have that, then you can pick one or the other point, whichever one you want, and use it with the slope in your point slope form. So let's take a look at an example. Given these 2 points, find the equation of the line that passes through them. So the first step we're going to do is actually calculate out the slope. So we're going to take 5 minus 1 and divide it by 4 minus a negative 2. And so we end up getting 4 over 6, which reduces to 2/3. So now that we have our slope, we can either pick this point or that point, your choice, to use in the point slope form. I'm going to go with this one since they're both positive. So when you plug that in, it's going to be y minus 5, that's the 5, equals 2/3, that's the slope, times x minus 4, and there's the 4. And that's it, we're done. We don't need to simplify, that's it. Easy, right? Okay, moving on. We have another form of a line, which is called the general linear form. You're going to find that pretty much every equation has a general form to it. And this general linear form is ax plus by plus c is equal to 0. And all we know is that a, b, and c are going to be integers. They are not parameters. We're not going to look at them as parameters, which means things that you can look at to help you graph or give you vital information like slope or intercept. They're just the coefficients of x and y and then the constant. Okay, so when you use the general linear form, the way it's used is maybe it's the book giving you a problem in general linear form and they're asking you to graph it. And so in order to graph it, you're going to put it into slope-intercept form. Or maybe they ask you to come up with the equation of a line, but then they say, put your answer in general linear form. Okay, so you're not going to use the general linear form to look at and pull out what's A, what's B, what's C in order to help you graph something or whatever. All right, so from the previous example that we got, our equation was y minus 5 equals 2/3 times x minus 4. What they might have asked us to do as an extra step was to put that equation in general linear form. So let's look at the process. Since a, b, and c are going to be integers, this fraction is a problem for us. So a nice way to get rid of that fraction, or to deal with that problem, is to look at the denominator and multiply the entire equation, both sides, by that denominator. Because what you do to one side, you do to the other, it keeps it balanced, right? So when I multiply this side by 3, I get 3y minus 15. And when I multiply this side by 3, this 3 and that 3 are going to cancel, and I'm just left with the 2 multiplied to this expression, x minus 4. Now what I can do is distribute my 2. So I get 2x minus 8. Still have the 3y minus 15. And my goal is to get everything on one side and have it equal to 0. And personally, as with most people, we like to have the x term or the first term to be positive. And by the way, this does have to go in order. X comes first, then y, and then c. You don't mix it up. Okay, so it's alphabetical. So I'm going to move this 3y to the other side, and I'm going to add the 15 to the other side. And I get 0 equals 2x minus 3y plus 8. And now I have it as a general linear form. Okay, moving on. Parallel lines have the same slope. I think we remember this, as well as that perpendicular lines have slopes that are opposite reciprocals of each other. This will be handy when they ask you to come up with the equation of a line and they give you certain characteristics of it. Maybe it's a line parallel to another line or perpendicular to another line. So that will help you get your slope. We've already talked about this. Slope-intercept form is y equals mx plus b. M is the slope, b is y-intercept. We did talk about this earlier as well. The equation of a horizontal line is y equals some number, and they just use b as a constant. It has nothing to do with the b from the general linear form. Okay, so here's an example. And the equation of a vertical line, x equals a, once again, don't worry about it. The a and the b, they're just variables or numbers, right? So x equals 2 is a vertical line going through 2. All right, so we talked about that. We don't need to spend any more time. Okay, so final example. Find the equation of the line in general linear form, given that it passes through this point, 2, 5, and it's perpendicular to the line that passes through these 2 points. Okay, so we kind of have to think about how you're going to solve this. What's the information that we need? In order to come up with the equation of a line, we need a point and we need a slope. Well, the point we've got. Here's the point, right? This is the point. The slope is going to come from this information, that the slope of the line is going to be it's going to be perpendicular to this line. So if I figure out the slope of this other line, I know my new line is going to be perpendicular to that line. So if I can get this slope, I just do the opposite reciprocal and I can get my new slope. So the very first step that I'm going to take is to actually calculate the slope between these 2 points. So I take 4 minus a negative 9 and then a negative 3 minus 7 and work that out to be negative 13 over 10. But remember, I want my line to be perpendicular to this line. So my new slope, or the slope of the perpendicular, I do the opposite reciprocal. So now this is going to be a positive 10 over 13. So now I have my slope. Here's my slope. And I have my point right there. I can use those 2 pieces of information to write my equation in point-slope form. So I plug this in. And then the next thing I'm going to do now is to convert it into general linear form. If they had said to leave it in point-slope form, we would be done right now. Wouldn't that be nice? Okay, but they didn't, so we got to move on. So we're going to multiply everything through by 13. So I get 13 times y minus 13 times 5, which is 65. And over here, the 13s just cancel out. Make sure you're not multiplying these by 13. Okay, you don't need to do that because it's going to cancel with this 13 and go away. So it's just the 10 that's going to get distributed to both of those. And now I'm going to move everything to one side, have it equal to 0, and I'm done. So this right here would be my final answer. Okay, that will be it for today.